Dear friends, I am back after a long time, and you may think that I have almost closed down my channel, which is not true because as an academician, I have a lot of work which involves research, teaching, and many other activities, and there are also family issues, so which has to be taken care of. In India, family is very important. Now, today I am going to speak about a book which I show you in the beginning. Probability Theory and Examples by Rick Durrett. This book is essentially for people who like to work on probability or stochastic process as a separate subject, or people who would like to work on mathematical finance. I would like to take the side of people who work in mathematical finance as a quant, not as just a high frequency trader. So, because I like the mathematics of finance, I enjoy it. So, I would suggest what are the important things in this book and why I suggest this book and what could be the possible drawbacks. And I have now learned from you certain YouTubers. One is somebody called Bioshala who speaks about biology and debunking pseudoscience, because there is a lot of fight between science and pseudoscience nowadays. This channel is pure science, pure mathematics actually. So we will not have any pseudo mathematics or pseudoscience discussion. We will have pure mathematics discussion. So I learned that he at the end of his whatever he wants to say, he talks about a book or a movie as a bonus. So I am also copying him. Sorry, Bioshala, you please don't mind. And I will also give you a bonus, and a very interesting bonus. So here is Probability by Rick Durrett. It's published by Cambridge University Press. Every good university library in mathematics should have it. I don't expect at all anybody, student, to buy it. Okay. And you should take it, but you should, if you can find it in your library, please pick it up. And if you want to seriously, you are interested in probability and especially in mathematical finance. So, what is any probability book which is written in an advanced level starts with measure theory and Lebesgue integration, because probability is the story of measure theory, but of finite measure whose total mass is 1, right? Means the measure of the main set, the sample space in this case, is 1. Probability of omega is 1. You know, this is one of the Kolmogorov's axiom. Now, that allows one to go more deeper into issues in probability, and hence deeper into issues of finance. Now, what are the things? This is published by Cambridge University Press. I want to show you. This is published by Cambridge University Press. First published in 2019. This is the 5th edition of the book. Though there are certain, I've seen in Amazon that, there are certain reviews which say, okay, the 4th edition was better written or something like that. But anyway, I have not seen those editions, so I'll just speak on this edition. I have bought it from my own money, not from my research grant, because I want to keep this book because this is a beautiful book. Not that every result which is here would be required for finance, but it is sometimes fun to read mathematics for the sake of doing mathematics. Now, please note that I am not advising anybody to buy the book, nor I am doing an advertisement based on the request of the publisher. The publisher doesn't know my existence. Please. Now, I have bought this book when I am 55 years of age. So I have a little amount of money to spare sometimes to buy a book which costs at least on Amazon around 4,000 rupees, right? So it's not that every day you buy such a book. Maybe once in 4 or 5 months or 6 months you buy one book like that. A lot of my books which I show you do come through my research grant. the CPDA, which IIT professors get. I think many other top institute professors would get it in India. It's not very much, but it helps. So, so let us see what are the contents. So here I am trying to show you the contents. So it starts from measured theory. But interesting part of this book is that this measured theoretic part, the examples are coming from probability. They talk about distribution function and all these kind of things. So they talk about semi-algebra and sigma algebra and algebra and all these kind of things which are related to finally probability, because the collection of events are probability, and given a sample space every subset need not be an event. So you will learn probability much better if you know at the very outset that every subset of the sample space is not an event unless the sample space only contains finite number of elementary events. If there are uncountably many elementary events, then every subset need not be an event. So that's not, it's beautifully printed book with lot of diagrams, and what is important about this book is its examples. So let me just read through the contents. Now you can ask me that what will be, who is Rick Durrett? Rick Durrett is a professor of mathematics from Duke University, so which is a very prestigious university in the US. So first we have chapter is measured theory, which is consisting of probability spaces, distribution, random variables, integration, properties of integrals, expected value means expectation. You have inequalities, integration to the limit. These are this monotone convergence theorem, dominated convergence theorem, bounded convergence theorem, Fatu's lemma, and all other things. Computing of expected value, product measures, and Fubini's theorem. This is what you really need, the basic measure theory for probability. Then comes the law of large numbers. So first part is independence, then is weak law of large numbers, strong law of large numbers. This is chapter 2. 1, 2, 3 is a must read for anybody who wants to do some application of probability. For example, if you want to do stochastic, for example, you want to do stochastic optimization, then these 3 chapters you have to know. It might not be of great help to know Ito integral, which is important for finance, but it is important to know about convergence of random variables. It's important to know about Borel-Cantelli lemma. It's important to know about many other convergence ideas, convergence in probability, convergence in distribution, because when you do what is called the sample average approximation in stochastic optimization, these things are essentially needed. So in chapter 3, central limit theorem. So without central limit theorem, there is no statistics actually. So in central limit theorem, we talk about de Moivre-Laplace theorem, weak convergence, characteristic functions, some chain of central limits, different types of central limit theorem. We talk about local limit theorem, Poisson convergence, Poisson process, infinitely divisible distributions, stable laws, and limit theorems in higher dimensions. Then you have martingales. Now once you come to martingales, you are actually in the domain where you want to study finance. Though martingale gets applied even in physics and all these things, but let us just concentrate on finance because I am not a physicist. So conditional expectation is something you have to learn, and to keep on remembering from the very beginning that conditional expectation is a random variable. Even if you learn conditional expectation of y given x, so ultimately you can show that this is also a random variable, the simple conditional expectation that you study in your basic statistics classes. So conditional expectation is a random variable. It is not a number. Just an expectation is a number. Conditional expectation is a random variable. So these are little small tips that you have to keep in mind while you do probability. So here you have conditional expectation, martingales. You have Radon-Nikodym derivatives. They study branching processes. They study Dub's inequality, square integrable martingales, which are important, uniform integrability and convergence in L1, extremely important for finance, backward martingales and optional stopping theorem. So these are important for finance. Then comes Markov chain, but there are a lot of things in Markov chain you might not need in finance, but very basic properties you should need. You should need what is meaning by that something as a Markov property. Now you can say that if I go to finance books like Streve, they give me quite a good amount of detail about what I need in probability to understand mathematical finance. Okay, but if you want to go at a much more advanced level than Streve, you really need to read these advanced books like Rick Durrett rather than just depending on Streve, because Streve also has certain advanced books which you cannot read if you just read his stochastic finance books. There's 2 volume books. If you read the probability part from the second volume, if you just read that, in some cases they don't give the proof, they give the statement. But sometimes proofs are necessary because those ideas are required for you to do your own proofs later on. So learning to do proofs is a necessary part of doing mathematics, just like learning to do problems. This is a misnomer. People say that you can just read the theorem and apply it in problems. So I can change a theorem, I can make an inequality in a given wrong way and create a problem just to satisfy that inequality. Will you accept it? No, because you have to learn the proof of a theorem, because you have to know and convince yourself that from a mathematical point of view, from the logical point of view, this theorem is correct based on the assumption it has. You cannot just say, oh, this is okay, I'm just taking this theorem, I'm accepting it because it's written in a good book, then I'll apply it. No, never do mathematics like that. Doing proof is as important as solving problems, and that I stress for all students who are doing mathematics. Please be happy and proud that you are doing a subject like mathematics. It is one of the greatest inventions of our great species, the Homo sapiens, right? So now there is something called ergodic theorems. They may not be always applied, you can just keep it on the side. But then you come to Brownian motion. This is something, if you want to study mathematical finance, you cannot just forget it. You have definition and construction, Markov property, Blumenthal 0-1 law, you have stopping time, strong Markov property, path properties, which is becoming very important nowadays, the Brownian motion, and heating times, Martingale's and Ito's formula. This is a beautiful chapter, one of the best. The plus point of this book is that this book is filled with examples. Then is application to random walks, multidimensional Brownian motion, and there's link to partial differential equation. So there's an appendix with measured theory details, which if you know measured theory, you don't really have to do. So here is a kind of book which, if you study chapter 1, 2, 3, chapter 1 to 4, a little bit of 5, 7, I would say 7, you can just keep it to 7 for the time being, to start learning mathematical finance in a deep way. So please, and of course I would expect you to do chapter 9 at least, even if you want to skip off 8 for the time being, but chapter 9 at least. So you can see the book is filled with examples, and that's the big, and the proofs are given in details, which is important. That is why you can use this book to learn proofs. Suppose just finance books will just give you a statement. Is the statement true? Can you remember the statement? Once you do a proof and understand it, you remember the statement. I will always remember the statement of a theorem if I understand its proof and I am convinced that it is right. So once if I go to apply, I will carefully think about what are those assumptions, because I have understood the proof, right? Because I know that the proof would not be true, that the result would not be true if these assumptions are taken out. That is why when you read a theorem, when you need a theorem, read the proof, and I am stressing it again, proofing is as important as doing the problem. I have told it like this one, you might say this old guy is just repeating things just like old people do, but I am just doing it for your good. That is from my point of view, which you may think that it's wrong. I accept it. But look at this theorems, etc. Here, everything is been given in a complete detail, basically. For example, laws of large numbers. For example, you come to things like large deviation. You see a lot of examples. You'll see here example, example, example. Three, four examples here on the other page here, right? On this page 93, a lot of examples. It's full with examples. So it's very important to go through these examples. If you ask me, will you teach from this book? And the answer is yes, I'll teach from this book. If I get a chance, I'll teach from this book. There are many, I have a huge collection of probability books which I would like to show you one by one. And these are for finance, but I would also like to teach from them. And because they're a lot of fun, and maybe it would allow me to write up some notes on probability. Because this subject is just tremendously beautiful. So these are the two things I've always liked in mathematics: probability, statistics, finance, mathematical finance, this part, and optimization, convex analysis. But a lot of convex analysis comes in finance, and we will talk about that very soon. Also, we have to talk a bit about link between physics and mathematics, but there's a link between physics and finance. A lot of big quants in the Wall Street are physicists, right? Which included the great Fisher Black, whose Black and Scholes formula you all know. Okay, so with this, maybe just I can show a bit of the book at different points. You can see this. It has a very good description of Ito integral. Here is the section on uniform integrability. Here, this is the section. So now let's come to the surprise, extra. I am also becoming a, seasoned YouTuber, which I am not, of course. So here is a beautiful book, and I recommend it for every Indian student. The Secret Lives of Numbers by Kate Kitagawa and Timothy Revel. She is a historian of science, and he's a journalist, possibly, for writing up the things. Global History of Mathematics and its Unsung Trailblazers. It just arrived today. I had a look, and it's beautiful, and it tells you the story of many mathematicians, unknown mathematicians, just like me. But those unknown mathematicians are much better than me. So here they talk about contributions not only from Greek and the Western countries, but also from Gupta period India, also from China. They talk about Aryabhatta, they talk about Barahamir, and of course my favorite Indian mathematician, Brahmagupta. When they talk about calculus, they start with the Kerala School of Mathematics, about whom we have spoken sometimes on Madhava of Sangramagama. Also, this book, let us see what is written at the back. So I will do a small reading from it, and it talks also about Srinivasa Ramanujam and many mathematicians of the modern age, whom history has just erased from our memory because of their maybe race, their nationality. Because it happens. Though science is universal, the laws of gravity is not different in US or in India. The gravitational acceleration, Earth's gravitational acceleration on a body is same, right? It doesn't matter if you kind of do any experiment of physics in a lab here in IIT Kanpur or a lab in MIT, it will be the same, with little changes, some errors because of the person measuring it. Otherwise, it will be the same. So science is same, but there is always this power play in science, and even if you do good work, you are many times removed from the scene because, okay, I don't need you. You are just from that country. Who cares about you? That kind of thing is there in science. But that is not the reason why you do science. Here, people who are unknown to the world, largely, are not people who would they are not people because they did science because they wanted to be known. They did it because they wanted answers to something. They were curious about something. So curiosity driven research is what takes humankind ahead. I'm sure if a person like nowadays everybody talks about getting grants. So if a person like Albert Einstein, talks about getting grant nowadays, with high probability his grant might just be cancelled for making. They will tell that you are making up stories, kind of stuff. So this is the thing, and so this is a book full of those people. For example, there is a huge flourishing of mathematics during the Gupta period in India, and that's very interesting to read. I've just read for a few lines. I'll read out to you in my that little series I have on readings on science and mathematics. Don't worry, now I'm a little free. There's a little break in the mid semester break. So few more videos will come on books on probability and also on some mathematical novels, and I will do some beautiful readings which I am sure you will enjoy. So thank you. Have a good holiday. It's a national holiday for us, and let's honor people as great as Mahatma Gandhi and people as great as Lal Bahadur Shastri, and also enjoy for mathematicians for whom the world revolves around in mathematics. So you too also enjoy your subject. So don't worry about name, fame, but finally someday somebody would recognize. So that is exactly what has happened. Someday somebody recognizes. Madhava of Sangramagama is already recognized. Aryabhatta is already recognized now. Brahmagupta, yes, these are among the best mathematicians of the world ever, right? So, and also there are Chinese people, there are other from people. See, this is a big world, and people have done what Babylonians had done a lot of work about geometry. So Babylonians knew about the Pythagoras theorem. They knew the proof possibly of doing, right? So they talks about woman mathematician like Sonia Kovalevsky, on whose life there is a movie, Too Much Happiness, based on a small short story by the famous short story writer Alice Munro, who got the Nobel Prize for in literature. So those stories are there. So this is a wonderful book. I'm sure I'll also start reading up many parts and enjoy it. So thank you very much. Hoping that we will soon have our next program up in the line.